Pharmaceutical companies now use a number of techniques, collectively called combinatorial chemistry, that allows a few milligrams of many related compounds to be made. Chemists use the word synthesized. These are computer control syringes that add reagents and solvents and carry out other operations in a pre-programmed sequence. In this machine, the syringes are here. It has 4 blocks, each with 96 reaction vessels. The reagents and solvents are stored in these containers. The 96 reaction vessels on this Teflon block are arranged in a 12 by 8 array. 96 different esters, for example, could be made from 12 carboxylic acids and 8 alcohols. The base of each vessel, made of porous Teflon, is called a frit. The vessel is filled with reaction mixture by the syringe. Emptying is done either by sucking out the liquid under vacuum or by forcing it out under nitrogen pressure. Scientists determine the type of compound that they hope will have the medicinal effect they require, blocking the action of an enzyme or binding to a receptor, for example. Synthetic chemists work out a sequence of reactions that will produce the desired type of compound. The combinatorial chemists program the robot to carry out an appropriate sequence of operations, adding reagents, heating, agitating, washing with solvents and so on. These particular instructions tell the instrument what solvents to use. A typical run of the machine can take around 12 hours and can be done overnight. It'll produce a library of 384 compounds with similar chemical structures. Combinatorial chemistry is often carried out using beads made from polystyrene resin. This is called solid phase chemistry. The resin is pipetted into the wells as a slurry with a liquid that is then sucked out. The resin has functional groups that allow the starting material to be bonded to it. The new molecule is built up in stages but remains attached to the resin so that there's no chance of any of it being lost. At the end of the reaction sequence, the products are released, cleaved, from the resin, usually using a strong acid. At the end of the reaction sequence, the compounds are handled in plates like this. Each plate contains an array of 96 different compounds. These can be sent off for chemical analysis and biological testing, still on the standard 96 well plates that are accepted by all the instruments.